Welcome to Azure Machine Learning, not just for the Fortune 500. Stan, tell me about yourself a little bit. What's this?
Sure. I work here with you, of course, data analytics developer. That's my title. And recently we've been doing a lot with data analytics, right? Ingesting big data, taking in Internet of Things, sensors, and working with machine learning. In fact, we just won an award for machine learning in our marketing campaigns.
That was all you. Congratulations.
Well, thank you.
And I'm Stephen Borg. I'm the co-founder and strategist here. And math background, absolutely love the machine learning stuff. Having a blast with it and working with you.
I'm learning a lot about neural networks, just sort of working together.
Let's get started. Where do we use machine learning? We're going to cover that. What's in Azure ML? Some of the out-of-the-box capabilities.
Sure.
I frankly love the stuff that Microsoft just built and lets me consume. I mean, I just think that's good stuff. So we'll talk about that. But then, more importantly, I'm using and building an experiment.
Yeah. I'm working with some of my Fitbit data we can take a look at later and see how that might help us.
Excellent. What is machine learning? And I guess we need to define that. And I'm going to ask you, what is machine learning? How are we going to define this?
Sure. There are a lot of different definitions out there. But for me, I would say it's something, a model that improves with more data, right? So the more data it sees, the more data it consumes, the better it becomes at predicting whatever it is it's doing.
Whatever outcome.
Yeah.
I like that. So I might start off with just a little bit of data, but as I gather more, I'll get more and more information about that data, or get better at predicting it.
Right. The machine's learning just like a human would.
I have Alexa at home, that Amazon thing, and I'll jump out and ask it questions and things like that, and it'll come back and respond. And I'm really impressed. Cortana's the same way.
Sure.
Siri again. Just those where I'm actually speaking to it, and it's parsing that, understanding what I'm asking in some way, shape, or form, and giving me back data. That's incredible.
Pretty awesome, and pretty soon we'll be able to link in with Cortana in Windows 10 or whatever it is, and sort of be able to understand our data better that way.
That's going to be an amazing stretch. That's some good stuff. All right. What can it do? I want to jump in on this one if I can, because here's some of the things that I think are very interesting. We can create algorithms that adapt based on existing new data, and you've mentioned they get better with time, and not just get better, but sometimes repartition completely differently. So we may have trends in what people are buying, and all of a sudden people are buying the latest fluffy toy for their kid or whatever, and it's skyrocketing. We're going to want to put that in our recommendation engine. And as people's behaviors change, it's something that we can get better with, adapt. It changes based on this influx of new data.
Absolutely.
I love the ability to predict outcomes. I think that's one of the key things that we want to use machine learning for, is to predict the outcome of some set of data. We have a set of data. What are we going to get to? I just ate a bunch of food. What's my weight going to be like tomorrow? Right? Yeah. That kind of thing. What's my overall trend line going to be like?
Yeah, one of the out-of-the-box thing is predicting when you might need to do service maintenance on some machinery you have, or whatever it might be.
Like that ThyssenKrupp elevators, kind of the case study for Microsoft.
Sure.
They ran it through here, and now they're sending people out to do maintenance on elevators before the elevators break.
Which, by the way, when elevator maintenance guys would go out, they would have to service everything in the elevator. With the predictive models, they'll know which pieces need to be serviced, and that way it cuts down on their cost.
And they get the elevator up and going faster.
Right.
That's amazing. They need to use this at SeaTac Airport on the escalators. There's one escalator that is always down. Maybe you don't need to predict. It's always down. It's just always down. It never works. There's always people working on it. Optimize. This is to kind of do better than. And this might be to sell more things, to identify opportunities for cross-selling. This is one that I find interesting, which is extracting hidden data. It's the unexpected knowledge that you can get out of machine learning. When you say, hey, classify these people into groups, classify these things into groups, and you're wondering, why is this in this particular group? How on earth did it get classified over here? And all of a sudden there might be some semantic information in the data that lets you say, oh, yeah, I had no idea, right?
Beer and diapers.
Beer and diapers, right? That's the classic example in machine learning. And then this one, the next one is fun, and people don't use it very often, but summarizing data into concise descriptions. You find this is done a lot in text processing. We can actually pull out critical features of the text processing and surprisingly convert that into mathematical vectors.
Yeah, it's really the sky's the limit. These categories are so broad. You can define many situations that would be used in your own domain.
Right. Yeah. Banking, Internet of Things.
Yeah.
I looked at some of our attendees have things that, pagers that they walk around with, and like click a button and it tracks their location, tracks nearby medical personnel. Those are the kind of things that data could flow right in and be processed very effectively in not just machine learning. I think that's a big piece, but Cortana analytics in general.
As a whole, yeah.
As a whole.
Absolutely.
That's near and dear to my heart. My grandma, who just passed away, my grandma-in-law, she actually was at a nursing home where they would track those sorts of things and were able to identify when she went into periods of high stress for her, when she was having trouble sleeping at the kind of towards the end. And it was some really interesting data that they were able to trigger and gather and get people to come in and assist.
So with machine learning, you may be able to find correlations between actions or times of day or foods or whatever it might be.
Yes, and correlate that data so that it's the predictive maintenance thing, right?
Right.
So you got people ready to maybe go in and help before an anxiety attack hits in the middle of the night.
Right.
I mean, these are things that you could, it's amazing pieces of data you can pull out.
Yeah, absolutely.
So where do we use it? You just said everywhere. And
it's wherever you can creatively find a use case for it. I think that's a big thing here. There are a lot of things that are just being used across the board. You have to use them now, right?
Yeah.
You say they're table stakes.
Yeah.
You have to have some fraud detection. You have to have some customer churn, recommendation engine. But more importantly, with the extensibility of things like Cortana Analytics, Machine Learning Studio, you can build models specific to your domain. And with a little bit of sort of thought and creativity and understanding your data there, you can jump ahead of the competition.
Yes, I'm going to give one example. I work with a company that supports software for 3 large credit unions, 2 on the East Coast, 1 on the West. And those credit unions are targeting individual markets. And they've segmented their market population, and they found that Oh, I was muted for just a moment. We muted everyone. As people are coming in, feel free to type questions in. We've got enough folks now. We'll keep most everyone muted. But if you have questions, feel free to jump in and ask them. But
Kayla's doing a great job.
She is
all that.
fantastic. One of the things that they did, they segmented their population, and I thought that was really interesting. And they found that a subset, a very small subset of their population, were intense users of their mobile experience. And that intense user base were college students. And they, based on their usage patterns and where they came from, they actually went out and sponsored some stuff at the university, like long-term sponsor, like let's name buildings after us kind of sponsorship.
Wow.
To attract those particular people because of the heavy engagement that they had. Now they looked at the profitability of that segment and it was low, but they looked at that segment as they grow older, graduate from college, start taking on jobs and roles and responsibilities. That very high engagement with them, they felt would translate to profit. And they could make that decision based on algorithmic data that they had just dumped through and segmented their population. It gave them new personas for their development stuff as well.
That's amazing.
I know, I love that kind of stuff, right? The financial industry just is a natural place. A lot of times financial industries have, dozens of data scientists on staff.
Sure.
This place didn't. They were a credit union that are 3 credit unions and a development staff that didn't have data scientists.
So that's interesting. The large corporations have these data scientists on staff. A small or mid-sized one may not.
No.
They may have developers that are maybe interested in it, maybe not, maybe have a background, maybe not. But the idea behind Cortana Analytics is democratizing data, right? That's what they push.
Yeah, and it's because we want to take that capability and push it down to organizations at the mid-level that can't afford to hire 2 or 3 data scientists to just sit and play with their data.
Sure, and that's what we can do now.
Mm-hmm. I love it. So here are some of the places. You all have read that, all of the attendees. What is Azure ML? Now that's because this is different. Now you can do ML on, I don't know, on probably your old Commodore 64 has some ML stuff to that one, but whatever you've got, you can do ML on it now. What is different with Azure Machine Learning?
Well, the great thing about Azure Machine Learning is you're leveraging Microsoft's R&D, right? Everything they have built out for Bing, Cortana, all of their resources have gone into Azure Machine Learning, and you get to use all of that right out of the box in a very sort of plug-and-play way, right?
Yeah, I think that's a very succinct way to put it. Yeah, it's their platform, and it combines with everything else. That's the neat thing too. You can grab data from anywhere, throw it into have a data factory, pull it in, and run it through your models and train your models and do all these crazy things, almost trivially in an automated fashion.
Sure, and if you do have data scientists, if you have worked with data a little bit, you can go ahead and plug those scripts in. Usually they're using R or Python, and you can plug those in as well as what Microsoft has. So you can use your proprietary stuff along with their stuff and really create a great custom solution for your industry.
Exactly. I went out and grabbed recommendation engines. I just went to GitHub, right?
Sure.
The font of all good things open source, right? Sure. And I said recommendation engine in Python. And there were dozens and dozens of these recommendation engines that use different techniques. And I was able to grab those, simply cut them, paste them, and then do a lot of manipulation, but I can get them into then something like Azure ML.
That's very cool.
Yeah, and it's an open source project. I dump it in, have it up and running in a place where I can generate then an API for it.
That's
so I can call it. It is. It's really neat stuff. So Microsoft does the Azure portal, and they give us an ML studio for the data scientist. Now, yeah, for the data scientists and for normal people too.
Right. It's all modules. It's sort of drag and drop modules. So you can really get started right away. You don't have to be a data scientist.
Are we going to see this?
We'll see it. Absolutely.
All right. A couple other areas. We can grab desktop data. We can put things in Azure storage, all sorts of things. This is a nice integration piece. We can create this API service, and it's just basically a REST API that we can call. We can call it in batches. We can call it once at a time and get data back. And then, of course, we can push that into our mobile apps or Power BI is one I do a demo of when I'm doing a Cortana Analytics look. And then here's just an example of all of the various pieces. I don't want to dive into all these because we could spend hours talking in each individual thing. But
plus, it kind of complicates a little bit. It's not that complicated, right?
This slide does look complicated, but it's actually simpler than that, isn't it? This maybe is a simpler one, right? You import the data, build a model, turn that model into an API, and then hand that REST call off to your development staff, and they'll call it. And you may be the development staff. You might be you might be all 4 of these.
Right. You even have the ability to monetize your API. If you come up with a great model, something you think is useful for a lot of people, you can go ahead and monetize that and allow other people to consume your API.
I know that Dun & Bradstreet already has their data stuff up there here, so we can start calling and asking things, who's a likely customer?
Sure.
Actually, and pass in some details, and Dun & Bradstreet comes back with a list.
Yeah, absolutely.
Which you pay for.
Very cool.
They're monetizing that piece. One of the things that I want to plug here is at the bottom, there's all these algorithms.
Sure.
Right? And it pays to have some overarching understanding of some of what the algorithms do. And there's a great Azure ML cheat sheet, which we're going to link to. But that Azure ML cheat sheet, great place to kind of get an idea of what these algorithms do. But the Studio sits on top of it, helps you organize all of those. But in the
operationalization.
Thank you. That thing, that's where you can start to give that endpoint that people can just consume it. Now, Microsoft has built a ton of these. And you can go out to the marketplace and buy them from Microsoft, where a lot of them are free or very inexpensive, and use them in your apps already.
Right.
I think might even talk a little bit about how old.
Sure,
point, right?
Sure. But that's these out-of-the-box capabilities that you were saying. You have all these great things that Microsoft has already spent time building out, putting the logic into, debugging, and now you just get to use.
Yeah, it's crazy. I think it's worth taking a look at some of these out-of-the-box capabilities that you can use today without needing to do anything fancy, without needing to know what is principal component analysis. What does that do? What does that mean for you? What's a neural network? What's backpropagation? You don't need to know any of that,
right?
Because some really smart people at Microsoft built that for you, and you can just consume it. It's called Project Oxford. That makes sense.
Yeah.
Good brand for smart kind of thing, right? Here's some of the services around it, and I just want to mention a few of these. And where there's the Vision APIs. These are when you're really just looking at images.
Images, yeah.
And it'll return things like this is building in a city or buildings in rural. I mean, it'll kind of tell you, give you context about it.
Right, you're looking at a bicycle.
Yeah, I know. Yeah. How does it grab that? And remember what a big deal it was when Google built out it wasn't more than a few years ago that the biggest AI thing on the planet was Google's
reverse image search.
It wasn't the reverse. It was Google's identify cats in pictures in the internet.
Oh,
that was the world's biggest AI thing, right? It was this giant neural network to identify photos of cats on the internet.
Sure.
And now it's free, right? Well, you get 20,000 calls every month for free, right? There's face APIs.
Yeah, detect your face.
Yeah. How old are you? Are you male? Are you female? It's embarrassing when it's wrong, but other than that. Speech APIs. These are predominantly taken from Bing. So they understand spoken text in, and they can read text back out, and getting better at pronunciation.
Yeah, we see Cortana doing that all the time.
Yep.
Right?
I still see her misinterpreting a lot of what I say, and Colin, one of our, you gave the last podcast with, or last webcast, and he's from South Africa. His accent is always funny when they're driving. He'll say things, and Cortana kind of tends to drive him to some place that really he didn't belong. He'll say, drive me to this location, and it takes him off. But it's getting better.
Yeah, with the more users, it's getting retrained all the time, and that's something you don't have to do. Right.
That's a great point. Is they're getting better. Your API doesn't have to change, but you're getting more accurate data.
Right.
That is a really good point. There's Lewis.
Oh, your favorite.
My favorite, because it's the language understanding intelligence service. Now, how is that different than the speech APIs? Well, Lewis can read text and give you analysis of the text in various ways, but it also has an input to allow you to give it some domain-specific information. And that's cool.
Right. So if you're a lawyer or something, it will know what a case study is in the context of your job.
Yes. And you train it with examples. That's the craziest thing. You mark up examples and send it in, and it learns your domain. And so when you're calling it, I want to know about, now I forgot, what's the latest version of the OS X, the latest version, Panther, or what, I don't know. But I want it'll understand that when I say that, this is what I mean. This is my domain. My domain is here. And in fact, what I love about Lewis is to train it in a domain, you can point it to a website.
What?
Yes. So here's the thing. You want to do, you care about technology. Like we're in the technology field, right?
Yeah.
So you point it at tech websites, it parses those and understands this is the domain we're talking about by just looking through examples on websites. You can just give it URLs. That's smoking cool.
Very cool. So when we say Python, it's not going to think snake.
Exactly. It's going to say, hey, you care about the language Python because it's a data analytics language.
Very cool.
Yes, yes, very much so. So here's some of the things that you can do for these. The Vision APIs, I should show that out. Just generate thumbnail.
Oh, yeah.
Yeah, that's a big deal. And how people generate thumbnails normally has been to just compress the image into a much smaller image.
Right.
Well, then you can't see what's on it, right? You can't see what's important.
It doesn't focus on the main part of the picture.
Exactly. And you can't just focus in and crop the outside because you might be looking at it from, and this will take, and it'll look at what is the, I'm air quoting, interesting feature of that image and make it the center point of that thumbnail. Is it wrong sometimes? Probably, but
it cuts out a lot of time of having to do that manually, right?
Yes, absolutely. There's the face APIs, detection, grouping of faces. Who's in this picture? Face identification.
Yeah, that's very cool. I love that it can sort of pick out a face in multiple, like in a crowd. It can find all these different faces, and you can then sort of parse it to the maybe the customers that you're trying to target. And you're like, oh, I would like 30-year-old white males.
Yeah, and boom, there you go. Here's a whole list of them out of these photos. Here's photos of that. Yep, sure. Crazy. If you're happy and you know it, they've got a thing added to this Face API that shows you smiling. Are they happy or are they sad?
Right, which would again may aid in some kind of marketing thing. You want to market something to maybe happy customers, and if they're sad, maybe
market something different.
Maybe chocolate.
Right, exactly. The speech APIs, this is our speech recognition, text-to-speech, speech intent recognition. Not available in Project Oxford yet. Not available in Project Oxford, but out there in the machine learning world now, they have trained a neural network. It's a large-scale neural network, and I think it was at Yale. I don't remember the university, but it was better at identifying people's emotions than other people were.
Wow.
So it could take a look at people and identify what they're feeling over time. It was a video-based piece, but very interesting. It was better at identifying emotions, especially hidden emotions.
Oh,
other
wow.
people would say, yeah, that person's happy. The computer says, no, 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 no. They're pretending to be happy.
Oh, wow.
Very freaky, but I love it. Right? That's the kind of capability, right? I welcome our new robotic overlords. And Lewis here, you can improve the models, determine entities, intent, things like that.
Yeah.
That's some good stuff. Here's some of the face APIs just to show you what it is. Here's an example. You throw it in a photo like this, and it'll tell you all sorts of attributes about it. Like there's this person, he's 31-year-old male. You see the roll, yawn, pitch on their head pose, identification of where their pupils are located. So you can use that for zooming in on pupils if you're doing something like a biometric type of a thing. Really interesting stuff that you can get. And it gives you the face rectangle. Why is that important? That particular face rectangle you get is generally the face rectangle that you use in all of the open source and private protocol facial recognition systems.
Right.
So you grab it, trim it, and that's what you would send to do the facial recognition if you were doing it in something else.
Right. So whatever you want to use, you all the data there to sort of make it extensible.
Right.
To anything else.
Now, what I want to stress is this is out of the box. This is not. You don't build this.
Yeah.
You send a photo to an endpoint, and it gives you this data.
You simply consume it.
You simply consume it. You don't have to build the model yet. Verification, send up two faces, determine whether they're the same person. There's, am I a twin or not is a website you can do that. Grouping faces, give it a bunch of photographs, and it'll say, hey, here's the photographs that have this person in it. Here's the photographs that have this person in it.
Very cool.
Yep, great for like family photos.
Yeah.
Identification, you have some examples of people, and it'll identify who belongs in which one. And then the vision APIs, again, I'm going to blow through these really quickly.
Yeah.
They're not, the idea is that they're there and you can use it. But you can understand the content in an image. Here's a person. You can see he's not a clip art. It's not a line drawing, and it's not a black and white image. Is it adult? Is it adult content?
Sure.
Is this something that you might not want to expose?
And that might be important for marketing or whatever sort of thing. You want to make sure you're not putting out controversial images.
Exactly, especially if you're you have a forum type thing where people can upload images of their anything, right?
Yep.
Screenshots and things like that. You don't want them uploading things that are going to embarrass you publicly.
Right, and then you can take it down with immediate action.
Yeah. In fact, if you don't mind not building all of that yourself, there is another service inside of Azure ML that you pay for that combines this service with several others that looks at, is it pornographic, also looks at, does it contain text that is inappropriate.
Sure.
It also goes in and identifies, is it copyrighted?
Right.
And it'll look through and find, the similar image search kind of thing, and find out if it's a copyrighted image as well. So things that might keep you out of jail, or at least keep you from getting fined, right?
Right.
For sharing those things. So it's an interesting thing, I think. The other thing is image colors.
Yeah.
And this can help to identify things if you happen to be in an artistic design studio or you're doing something in marketing. You want those colors.
Absolutely. And again, as we're seeing sort of our world being digitized with like Google Street View and stuff like that, we're now able to sort of pull text just from pictures. It helps you sort of just scan any text thing. I know we had talked about having immediate translation, like you would take a picture of a sign in, let's say you're in China or France or something, and get the result in English.
Brilliant. And actually Bing has that, right? That capability. It's already in Bing. It's that translation. This is really interesting for me because I just recently took the Andrew Ng, the professor at Stanford, and I took his online course. Mm-hmm. And he ended the entire machine learning online course with an example of finding text in images. And it is brutal difficult to do on your own.
Yeah.
It is an amazingly difficult thing, and it's really easy here.
Yeah. We're getting better all the time, but again, this is leveraging all of the work Microsoft has done, so you don't have to understand that.
That is the craziest thing. You know what? Can I show how old?
Let's do it.
I just want to show HowOld.net. I'm gonna open up a browser here, and let's go to HowOld.net. And I just want to show you that. Look at HowOld.net, and you can search these faces. Like, let's use this photo. I don't know who this is, but we're going to use this photo, and we can say upload this, and whoa, it's a male who's 36 years old, right? And there's the bounding rectangle, and we can see, sorry if we didn't get this quite right, we're still improving this feature. What I love about HowOld.net, and I've got to say, is somebody was just showing, this was a demo site for, what was it, Build?
Yeah.
I mean, it's just a demo site that somebody slapped together at Microsoft so that their boss could have something cool to show.
Yeah.
Their boss gets up and shows it, and when you look at the history of the hits and the analytics on this, they're still getting millions of hits a day on this site.
Because it's so cool.
Because it's so cool, right? And all it is, it's this trivial site where you upload a photo, it goes out and determines how old you are, puts the bounding box, and they just put a nice graphic on it.
Yeah.
I wanted to throw myself. Everybody uploads their picture. How old do I look?
I honestly thought you were going to say you love it because it told you to look 25.
Well, that too, right? But it's really interesting. And then they've added all sorts of things. Like here's the magic behind it. You can tweet it. There's lots of people have shared it on Facebook 2.3 million times.
Yeah, it's just kind of fun to play with these novel sort of things of machine learning, but that you could leverage.
Yeah. How old is this woman? I don't know. Let's find out. 36 and female.
Perfect.
This is cool. Anyway. It was worth, I think, pulling that up just to see that you can build these things. And again, this was built over a couple of days before the demo would connect.
Right.
And this is not this website with millions upon millions of hits. By the way, it's a good thing they built this thing in Azure because it went viral, and they had to spin up just an amazing amount of servers in the back end to run this, right? And it just auto-scaled up to infinity, basically.
That's what Azure was made for, right? These bursts, these high spikes, being able to scale automatically, stuff like that. That's why I think we've used it a lot with our big data and IoT customers, just because it can scale.
Yeah.
You don't want to pay for that high throughput when you're not using it.
No, but you also don't want to get /dotted and then have your website fall over, right?
That's right.
In fact, I don't use /dot even a thing anymore. I mean, /dotted, usually someone would post something on /dot, and boom, it would take down these sites.
Yeah.
It was Super Bowl Sunday, right? Boom, an ad would go up and everybody's website would fall over, right? Even though they thought they scaled for it. Anyway, we're getting off topic. Let's get back to machine learning. And I think over to you. You've got some interesting stuff. And people can't see Stan. We're not doing any visual here, but Stan is one fit individual.
Oh, well, thank you, Steve. I appreciate that.
He is in absolutely fantastic shape. So he's going to take over.
Let me take over
this
here.
Desktop.
Show my screen, and hopefully you'll get that in a second.
And I'm seeing your screen.
Okay, great. So recently I had bought a Fitbit. Right, I'm wearing it right now. Yep. I've been trying to log everything I can, and I just want to run it through machine learning, and partly so I could expense the watch.
Hey now.
Well, I tried. Okay, so what I did, so on Fitbit, they have the premium service, and what you can do there is export all your data as CSV.
Okay.
So I did that, and I pulled it down and parsed the data out and uploaded it here to Azure Machine Learning Studio. And we can sort of look at that now. Let me just zoom in here. And what I have is I have my food logs, my daily totals of calories. I have my weight, my sleep, a whole bunch of different stuff, my activity level, and I'm just slapping it all into Azure Machine Learning Studio. We can take a look at some of this data. Let's see, what do I want to expose about myself here? Here is my food log. You can see
taking a little bit of time to come up.
Okay.
So just to let you know that people can't. Oh, there we go.
There we go. So for breakfast, I would have my protein shakes with some oatmeal before I exercise. So there's all of this data, and all I'm doing is here I'm going to cut down to the columns I actually am going to use. With these metadata editors then, I can go ahead and cast those fields as strings, date, time, as categorical or not, right? So breakfast, lunch, and dinner would be categories.
Oh, that makes sense.
That I want to sort of look into. Integers, doubles, whatever data that is, I want to cast it just so it has a little bit better understanding.
Right.
And so as I go down, I'm taking all this data, casting it, and joining it together with these joins.
So basically all of this is your data cleansing part.
Right.
You're just really cleaning up your data, making sure it's ready to be dropped into the machine learning algorithms.
And honestly, Steve, that's probably what 90% of it, right?
Yeah, that is. Just to let everybody who's attending know that. You gotta love cleaning data, right? you gotta have a passion for getting rid of those extraneous data points.
But I think that's really cool, actually, because most of your time is going to be taken with just trying to understand your data and clean your data. That means the actual building of the models is really kind of trivial compared to that.
You know, that's a great point. I remember building my first neural network back in the 80s, right?
Sure.
And I spent the vast majority of my time coding the neural network.
Right.
That was where I spent almost all my time, right?
Sure.
Just building it and and now, well, that's just a drop down, right?
Right, right.
And I'm done. So, yeah,
Absolutely.
Good point.
Okay, so I'm taking all this data, I'm going to join it together, and I have several joins here. And then I'm going to project the columns I want.
What does that mean?
That means, so when you're pulling all these together, you'll see I joined on the dates, right?
Got it.
And so what it'll do is it'll give you a data frame with just a bunch of dates. I don't need all those. I only need one date column.
Oh,
right?
yeah.
So if you see here, I'm taking all the columns, but I'm excluding these extra date columns that I joined on.
Okay.
Or perhaps there's just something you won't need there, and it'll just add noise to your network, and you'd say exclude that column.
Sure, that makes sense, because if you have 4 columns with identical dates,
sure,
that's going to weight whatever it is you're doing 4 times almost on the day. It'll say, ooh,
right.
date is really important, as it may influence the data and the projection.
Yeah. So, and then all I did here was I pulled in a neural network, and we can sort of look at that stuff. I had already trained models, we can say. Anyway, so if you go down to machine learning, there are all these different sort of tabs, and you can see these are the main sort of portions of your experiment, right? You're going to initialize it with something.
And there's, yeah, it looks like we've got things like anomaly detection or classification or clustering and regression. There's various types of things that you might use.
So because here, what I'm trying to do is predict my weight for tomorrow based on what I've eaten and how much I've slept and my exercise and stuff for today. So because that's on a continuous scale, I want to use the regression.
Got it.
Right? So I look in here, and there's all these different sort of regression models we can use.
So you picked the neural network regression. Why did you pick that one?
I picked that one because when I was doing this earlier, actually I picked quite a few of them just to try.
Ah, okay, got it.
So I tried all these different ones, and the neural network ended up being the best.
Yes! Yes! Having had a history in neural networks back from college, I very much am happy to hear that.
But the great thing is you don't have to know which one's going to be the best. You just pull these modules in, connect them up, and you can test it, right?
Well, how do I test it? Well, first show me the output of this, but...
Sure. And then I train the model, and I just score it and evaluate it. So if
What's the difference between scoring and evaluating?
Sure. The scoring is the prediction itself.
Okay.
Right? So when the neural network goes through, it's going to look at some of this data, make these predictions on, I'll show you here, on the weight field. Okay. It's going to try to make these predictions, and then it's going to grab some of the extra data that we've split on right here.
Okay.
So we have the training data coming in, and then we have the scoring data. It's going to grab that data and try to score it against the data it hasn't seen yet.
Got it. So you take some of the data and then train it, and then you predict on this training set what the weight is going to be, and it'll look and say, here was the weight the neural network said, and here is the weight that it was actual weight. Do they correlate?
Absolutely.
Interesting.
So we can sort of just take a look in here, and this is the final output of everything, and now we can see the scored label. So this is what it thought I would weigh that day, and if we come over here and we find weight, where's my weight? Right here, this is the actual. So it's kind of tough to see here, right? You'd have to go through and sort of look at the score versus the actual.
Sure.
So then we'll come and we'll look at the evaluation. And just visualize that. And we can see how close it is, right? The lower these are, the better.
Right, and look down here, when you take a look at the error, that first bucket of error, down, is that 0.12 pounds? You're measuring in pounds?
I'm measuring in pounds, yes.
That's pretty close.
Right.
On an accuracy of calculating your weight, right?
Absolutely.
And it makes sense because your weight is going to be similar to what it was yesterday.
Sure.
But when I looked at your weight, just on those two, you went from 191 to 197 in one day. That's a 6-pound difference in one day.
Must have been Halloween. That's right.
Yeah.
And so in the future, what I'd like to do is correlate that to how many carbs I've eaten.
Right.
How much sleep did I get the night before? How long was my exercise? Which exercise did I do? Was it cardio? Was it resistance training? I would like to know, there's my body fat. I would like to know if that weight correlates with my muscle mass or my fat.
Yeah. Yeah.
And that's all stuff I plan to do in the future. But and then what I can do is I could go ahead and make this a web service, right?
Yeah.
So all I do down here is I would click this, and you can see I've already made this a service.
Mm-hmm.
And all that will automatically just sort of rearrange everything stuff for you. Let me retrain it.
Look at that. It pulled out some interesting things.
Yeah.
Here, it added some nodes, some input and output nodes.
Absolutely. And then we can go ahead and run that.
So basically what it's doing is adding some features here so you can input your data. You can give it the various, your weight, what you've eaten, all of those things for the day.
Absolutely. So it'll actually create those endpoints for you, right, of how to interact with it and what your output is going to be. And that's just what we saw it doing.
That's amazing. And now we just call it via REST.
Right. And we could even publish it to the marketplace. And if it's something I thought was, oh, this is really cool, people are going to use it, I could try to monetize that.
Sure. Very interesting stuff. Now, again, this particular data, because it's all just you, is going to be probably, I'm air quoting it, overfit to your personal weight gain or loss based on what you eat.
Yep.
If you're 120 pounds, you might have a totally different gain weight profile based on that. But who knows? This might be able to predict it. Oh, we need to throw mine in there and see how no exercise and way overeating how does it impacts this.
Okay. Well, maybe now I should just sort of hand it over to you.
That sounds good. We can pop back over on me. And we're going to go back to my screen here, and I want to just walk through a couple. Whoops, and went a little far.
It's a reveal.
It's the reveal. That's it. Yeah, I went way back, didn't I? Some of the things. This is the Azure ML cheat sheet.
Yeah.
And I want to come back because I want to help people get started on this.
Okay.
It's not rocket science.
Sure.
Even though this is rocket science. I mean, really, the people who created the algorithms that are used behind the scenes, that's rocket science. Right. That is an amazing. I mean, when we start talking deep neural networks, which are multi-layer neural networks that are pulling out things like, pulling out people's emotions on hidden emotions.
Right.
People are faking it, kind of thing. That's a really big deal. And to do that takes a team of research scientists a lot of times. So I don't want to trivialize the algorithms, but I also want to stress you don't need to know jack to use the algorithm.
Right.
I mean, it helps to know. You want to put it into the right thing. You're not going to use regression to classify things. And you could, but it's a little wonky, right?
Well, I think Azure ML was made for experimentation. That because you can sort of just plug and play and go through really quick, you're supposed to play around.
Yeah.
Figure out what works. Try it.
You know what? That's a good point because one of the things that you didn't show in this webcast, but you could have, if given time, you can take that neural network model
Yep.
And you can take another linear regression or another regression model, maybe a nonlinear regression or a linear regression or a forest tree or whatever you want to do, plug it in, and then put 2 pipes into that evaluate model, and it'll compare the 2.
Yeah.
And it'll tell you, hey, this one predicted better.
Absolutely.
I know that last time we gave this presentation, we had some other data, and to my enormous chagrin, a linear regression model beat the neural network, which almost made me cry.
I know.
But let's come back to this cheat sheet, because it just says what kinds of these algorithms should you be using. Now, do you want to predict things like categories? Well, there's 2 class classifications, perfect for, is this customer at risk of leaving?
Yep.
I mean, that's the customer churn prediction is a 2-class prediction, because you've got they're going to leave, they ain't going to leave.
Right. And you get a confidence interval with that.
Right, exactly. And then you can go up to multi-class classification, which might be something like, is this a customer that's going to leave? Is this a customer that's kind of a little slippery? Or is this one of our diehard fans? And if they're a diehard fan, you might want to give them some, price increases or something, because they're never leaving. You might want to treat them right.
You can see if they're going to be, are they your gold customers? Are they your silver, bronze customers? Who is in these categories likely to consume certain services of yours?
Right.
And who is not?
And what's, I think, really interesting is this is when you know the categories. Those 2. You know the category. You know who left your company.
Right.
You know who customer got up and went to another carrier. Right?
Absolutely.
You know those things. But there are times when you don't.
Yeah.
And we have one algorithm currently. Now there's dozens and dozens of algorithms we could use for this, but one of them here is k-means clustering. This particular one happens to be so effective at this model that we can discover the structure. So we can just take a group of customers, products, and whatever. Well, you have days, right? You have days of consumption. You can just say, show me what days are like other days.
Right.
And it might come back to you and say, these days are alike. And it may be that these are the days that you ate ice cream for some reason or another, right? These days are similar to each other, and you don't know why until you start digging into the data.
Right.
And that means you can start to discover patterns in your data. And this is where I think data cleansing is a good thing too.
Sure.
Because when you start spelunking through your data to making sure it's clean, you as a human who has a very powerful neural network are looking at the data and understanding kind of the structure. And so when you look at something like k-means, you can understand what the clusters mean. You can logic it out sometimes.
Right.
Because it doesn't specifically tell you these are why they were clustered together.
Right. Yeah. I may find out when I get less sleep, I'm more prone to eat ice cream.
It could very well be.
Right.
Very well be. Anomaly detection. This is finding unusual data points. Yeah, and this I think is neat. You've got 2 main ways of doing it. The support vector machines, which basically divide things into categories, and some of those categories are outliers or anomalies.
Sure.
Another one is principal component analysis, which looks at what of all the variables, what are the important ones that describe this data?
Right.
I love that there's a face one, right? You have principal component analysis on a face, and it basically you give it a bunch of faces, and it creates from those faces the prototypical human face, and then it says how far away from this are you from that face?
Right. Yeah.
And you happen to be in this vector away from the face, and other people are different vectors away, and you can determine how similar people's faces are based on the nearest, how close those vectors are.
They couldn't see it, but when you said mine, your hand went way out, like I'm way over here, and other people's is very close. So thank you, Steve.
You're just this complete outlier out there. And then regression models, and we talked regression. This is predicting some continuous variable,
like price,
your weight, all of these things.
Yeah, distance, anything that's continuous.
Right. And there's a lot of good ones for those. And so this is where you start, and then you can compare among these various things and determine which one is best.
Right. So yeah, you don't need to know the difference between a naive Bayesian model and a neural network or boosted decision tree.
No, absolutely.
Just test them out.
And do they work?
Yeah. Which one's best?
Which one's best for this particular thing? We've already talked about building an Azure ML model.
Sure.
And so we've discussed that, and so I'm then just going to do my causation. Correlation is not causation.
The word of warning here.
The word of warning. Neural networks, boosted decision trees, linear models tend to not overfit. They tend to underfit your data sometimes. You have to you don't just want the best model on your training data,
right?
For instance, and because what can happen is you can. We talked about this earlier. If all the data I have is Stan,
yep,
and then I use your service with my data and my input, it may not give data that's correlated well. Right? It may come back and say, "Hey, you're going to be 191 pounds tomorrow." I would be like, "Woo-hoo-hoo! Right? Yes," and that may be completely incorrect.
This is why it's important to split your data as well.
Right? Yes. Yeah.
If you trained it on all of your data, it would overfit to those data sets you gave it to learn from.
Exactly. So you really need to split those out, and so you need to be cautious and concerned about how those get split out. And the jelly beans cause acne, right? This is in a level of confidence. You know, the scientist or the business person runs in and says, jelly beans cause acne. Scientists investigate. So off they go. And it says we found no link between jelly beans and acne with a probability of more than 0.05. Right? And then they come back and says, wait, but maybe it's only a certain color. So they test all the colors of jelly beans. Well, if you're testing more than 20 colors, there's a pretty decent probability that one of those, by random variation alone,
right,
will cross that threshold.
Correlation is not causation.
It's not causation, exactly, and it's very careful. So we have these news, jelly beans linked, green jelly beans linked to acne with a 95% level of confidence.
Right, certain things are just going to correlate just because that's how statistics work.
It is, and what's so fascinating for me, and this is maybe a little bit of an aside, but we have to be very cautious with our data. There is a new movement, it's called the reproducibility movement, that is looking at data from social sciences specifically and reproducing the research. So they're taking the exact same research and reproducing it. And what they've found, and I don't have the exact numbers, but it's more than half of the studies cannot be reproduced.
Oof.
In other words, because it's what gets published, right? So there may have been 500 studies, but if nothing jumped out at you,
right.
if you found if nothing, no jelly beans cause cancer, you don't publish.
Right.
But when you find that green jelly beans are associated with, you publish.
Right.
So there's this statistical bias inside of journals that are producing scientific evidence. And when you can't reproduce more than 50, and so this is spreading into medical journals as well. And they're finding the same thing, irreproducibility of scientific studies in medical journals as well. So we're hearing things like, coffee causes cancer, or coffee cures cancer, or whatever this is. And there may not be accurate because of that. And the same thing can happen. We can group things into our models.
Right.
We can do a k-means clustering, and we can think we understand there's some causal things, but it may just be an artifact of the statistical anomalies inside of our small amount of data.
That's right. It's so important to really understand your domain and your data so that you can know when something is actually causation or it's merely correlation.
Yep, and what's fun is that with machine learning, as we get more and more data, we can plug that in, and that's a further validation of the model, right?
Right.
And like you mentioned right at the beginning, let's retrain this, let's learn, let's not just say people who buy diapers also buy beer if it's after 5 o'clock. I mean, that's a known correlation.
Right.
We didn't have a causal model. We had suspected causal models behind
Sure.
that, right? But that may evaporate over time.
Right. It doesn't mean if you're buying toilet paper, you're going to buy beer.
Right.
Absolutely.
Excellent. What can it do for you? Just quickly, why? There's a bunch of people on the call now. Why would they care?
Because we are now entering the age of data. You can't get it right. You can't compete anymore without understanding your customers, your business, where things are going in the future. You can't be reactive anymore. You have to be proactive.
I think you're absolutely right. I mentioned table stakes. If people complain they can't compete against Amazon, they can't compete against Walmart, they can't compete against, no kidding, these people have data scientists,
right,
who are optimizing it just down to the nth degree what kind of stuff they're getting. You can compete.
Right.
And I think this is an area where we need to be able to have at least some insight into what it's. I think this is back to the 90s. Everyone needed a website in the 90s.
Yeah.
It didn't matter if you were the mom and pop store down the street.
Right.
You had to have a website. You had to have a presence, so you showed up on searches so people knew where to go.
Well, I just want to quickly say, because I know we're running out of time, there has been some barriers to getting inside, and one of them is retaining data or collecting all the data. Having enough space to do that has been a barrier. With stuff like blob storage in Azure now, it's so cheap.
$30 per terabyte.
Right, right. And you can integrate machine learning and Power BI just super easy, so that there's really not an excuse anymore.
Yeah.
And the barrier to entry is becoming less and less. So if you're not collecting that data, if you're not trying to predict where you're going, you're going to be left behind, and there's no reason for that.
Well, I think Northwest Cadence is a great example of that. I mean, we don't have gigabytes of data,
Sure.
but we do have data from our website. Who
Sure.
clicks what articles? What do they drill into? We send out a newsletter to several thousand people, and those clicks, who clicked through to what, how they clicked, what was interesting.
Right.
This is the data that you gathered and dropped into machine learning to help us identify what types of articles are people interested in and what types of information should we provide. Right. And we're a small company, right? We are not a Walmart, right? And yet we can extract value and data from this.
And the great thing, I use their out-of-the-box semantic analysis to be able to look through our blogs and see what is the overall tone here. What do people respond to? Do they like the really dry technical articles,
Yeah.
or is it the more sort of narrative ones?
That's brilliant. These are these. How do we even write? Who writes? These are really important things to answer. And so the idea here is take your data and run with it. And there's another thing that I want to mention probably before we go further, which is you can integrate this with things like platform as a service and all of the other areas. You can pull these in, not just to sit in front of your monitor and look at the website and then walk over and say, we need to write more narrative stories. That's what's grabbing people's attention. What we can do is we can take that and predictively put it into some application so we have a more intelligent application. And that's what the platform as a service is. We can start to scale these things up. Maybe in our WordPress site, when people go in and they're creating a blog, maybe we should put a little thing that says, hey, here's your readability index based off of the semantic analysis, but more importantly is here's the traction we think you're going to get based on this blog post.
Right, yeah. When I write something now, I sent it through some semantic analysis. I want to know.
Yeah. That's so cool. We're out of time.
We are.
I want to just very briefly mention that at Northwest Cadence, I know that this stuff is fun, and we are happy to help folks do this kind of work and just get you kick-started on your data.
Oh, sometimes I think you and I get a little bit sidetracked just talking about machine learning and stuff.
It's so incredibly interesting, and it's so incredibly applicable to almost every company we've talked to, especially the ones without data scientists. It's what blows my mind.
I love the creative aspect of it because there's a large creative component of figuring out how are we going to use this data to get this insight.
That is absolutely correct. And you know what? I'm going to put in here. I'm sorry, this I don't know why this ended up here. The slide said welcome, but that's I'm at Stephen Borg, and I'm at stephen.borg at nwcadence.com.
Yeah, and I'm your stan.low at nwcadence.com.
That's STAN period DOTLOE.
That's
yeah,
right.
That's right. That can be a confusing email address. And I'm steven.borg@nwcadence.com. Thank you all for attending, and we will talk to all of you later.
Absolutely. Well, again, any emails, I'll be happy to respond to.
That sounds great.
Okay.
All right.
Thank
Talk
you.
to you all later. Have a great day.